And
Recording in
yeah, from the team side, if you may mute yourself because your voice is echoing in here. So it will be great for me to have the continuation. So hi, hello everyone, very good evening. So if it is possible, again, I request you all team members to like turn on your video if possible. Then it will be a great interaction with you guys doing the hard work, learning something from these classes. So I hope each and everyone already went through the questions and the PDF itself, which I gave earlier during my classroom program. And further, I'm going to give some of the assignments, but before proceeding to the assignment part, I just want to acknowledge these peoples who joined the classroom program in Tinker CAD, and I love your effort, and I personally love to like get in touch with you guys and further contribute in the field of STEM, robotics, and AI. You are the genuine person I do have in my classroom program who do at least try to follow the things I try to mention. That is not recommended or not need to do, but yes, if we talk about the continuation and the process we do follow, yes, some of you have to go through each and everything. If you already do have the knowledge in this Tinkercad platform and all, that's a different story. There is no need to say that. When did you share the classroom code? PR sir, yeah, on my first or second day of thing. Okay, let me share this class link again back to the chat window so that each and every person can able to do the designing stuff and all the circuitry development in one single place, so that it will be easier for me to find out the problems you are facing throughout the classes. Otherwise, how I will come to know that you are facing certain problem, and it will be not possible. It will not possible for me to resolve the thing accordingly. So if I click on one of the teachers profile, if I click on Prabhas map and okay, just let me go back to the okay, just let me go back to the page and let's see who already submitted any of the things. So Megha ma'am also not did anything. Okay, let me go under the activity.
You can check mine, Lakshmi Subramanian.
Yeah, Lakshmi ma'am. Yeah, Lakshmi ma'am, you created something which is not visible. Let me see again. Okay.
It is actually the circuit that I had been working on, not the designs,
The
the
first
circuits. This is the first one you already saw. I'm talking about the circuit.
Okay, let me go back to the circuit one. And yes, you completed several examples in there. That's wonderful, actually. Yes, you already completed some of the examples. So this is the reason why I wanted to you all to join over the classroom program, so that I can also able to see the designs and further help you to resolve the problem related to the gates and all electronic circuit. So I believe some like all the members did not have the access for this aid. So I just copied the link and pasted it to the chat section so that you can also able to join the same class. And this is not for me, this is only for you guys, so that you can able to like go for the designing stuff and come up with the problems. Then only I can able to provide you the solution. Otherwise, what will happen? I will only speak out the things which is necessary, and the tools, like the details of tools and each and everything. So apart from the details, I will not be able to like resolve the problem. So as Taufik sir explained some of the circuitry experiment in last class, I believe you already understood the few basic things in the Tinkercad platform to do the circuitry simulation, right? So I'm creating one more activity in here so that it will be great for you to add on in this one. So I'm just clicking on it. And as the way we explained earlier, like if you have to go for the circuit designing, then you just have to click on the circuit. And the time when you click on the circuit, you will land on this particular page. And let me introduce this page first. So on top of it, we do have is the naming section. So I will write down the first circuit, or even though if I have any specific circuit name like LED glow using battery and all. So just try to rename this stuff before proceeding to the final completion of the project. So we do have similar tools like I mentioned earlier. We do have a notes tool and copy tool, paste tool, delete tool, undo and redo button. And on the left hand, on the right hand pan, what we do have is the components. Each and every components related to electronics is mentioned in here. No, I believe each and every, not each and every, because the applicable components, or I can say that the required component, not the basic component, is mentioned in here. But if you find any difficulties utilizing other components in your project, then please let me know. I do have one more simulation platform, one software in which you can able to add your customized version of different electronic components like the small parts and all. Even though some of the capacitors are not properly mentioned, only the disk type capacitor is there. So apart from this, we do have Arduino, microbit, and circuit assemblies and all. So if I just click on the Arduino one, you will find plentiful of examples which we will do in our next class. But for today, I love to like resolve your doubts and share some of the basic insight to start with the Tinkercad platform. As already Savi sir mentioned in last class, you do have the breadboard and the battery system and all the things like the slide switch and the LED itself in the Tinkercad platform to perform simple experiments. But on top of it, I would like to explain some of the things before proceeding to the experiment, so that it will be a like more addition to your knowledge, a value addition to your knowledge itself. So it will be great for you to explain these things in front of your children, in front of your students in the classroom program. So whenever we look into the breadboard, we can see there are several holes, like a lot of holes are there, especially. So we do have two of the specific section in this breadboard. First, the above on top of it, in which we can see the line is connected horizontally, right? And below also we do find two of the holes which is connected in horizontal fashion, and the name of these holes are termed as positive and negative. So whenever you try to utilize the breadboard in your practical application, remember we do have two of the power section on top of the breadboard, and below horizontal line we do have the power section. And apart from the power section, you can see the alphabets are mentioned in the picture itself, and several numbers like 1 2 3 4 5. So these particular space is used to place each and every components in the breadboard for perfect like the perfection to make the circuitries and all. So you have to remember each and every time whenever you use the breadboard, you remember the middle portion will be always connected in the in the vertical fashion, and the top section, which is the power section of breadboard, is connected on the horizontal fashion. So whenever you connect anything in the first hole, then it will be connected throughout the horizontal line. And similar thing happens, but the opposite happens to the middle section. So middle section is divided into two of these sections. So we can utilize either one of these section to like accommodate each and every electronic components. And further, if we connect anything in the point one or JI, if you already do have the knowledge about the matrix, you can understand my word. The J1 is the first point in this section, and in J1 you can, whenever you connect anything to the J1, then it is connected throughout the F1, G1, H1, and I1 mathematically, right? Sorry. So now what we do have is the arrangement. So here to arrange each and every components in the breadboard stuff, you can do the following. You just have to drag and drop the component in this fashion. And suppose if you do not have, like if you want to connect the LED directly to this particular portal, but this particular line is connected in this fashion, like the horizontal one, then what you have to do, you have to tweak your components, right? So to tweak your components, what we do have is the tool above on top of it. Either we can able to do the rotate and mirror. Mirror will just mirror the object in the X plane, and it will just change the polarity, side of polarity. It will change the side of polarity like the anode and the cathode ones. So here, what we need to do, we need to rotate this object a little bit so that we can able to fit the road object or the components directly in the power section. So I'm just rotating it a little, and then I'm just dragging this component directly to this power section. So now the cathode and anode is placed properly. But you will find one problem with the cathode and anode, as cathode represents the negative terminal of the LED, right? And anode represents the positive terminal of LED. So what we need to do, we need to rotate this mirror, or like rotate, we don't have to rotate this, we just have to mirror this component so that the sides will be switched. So terminals is switched, and now what we do have is the cathode on the negative side of breadboard and anode on the positive side of breadboard. So now this thing we can able to connect directly to the power section without needing any further assistance using the tools we do have in the Tinker CAD platform. And further, if I drag and drop these thing in here, but it won't work properly because each and every lines, each and every dots is connected in the systematic way. So again, we need to rotate this object or the component so that we can able to utilize the other pins in process. So now, why is there a need to rotate the object and to place it properly? Let me show you one of the examples. Suppose I do have the battery with me, with the 1.5 volt battery, and now if I want to connect this battery in this pin, it won't get connected, right? So we need to rotate this battery a little bit uh, in the negative direction of 90 degrees. So now this is properly connected in this port. But in this situation, you can see the terminals are not properly aligned with the terminals mentioned in the breadboard. So what you need to do, you have to mirror the object, and mirroring object will help you change the polarity, the sides of polarity. So through this, you can able to have the proper outcome of how you are going to operate different things in Tinkercad platform. And further, what else we can do in Tinkercad platform is to like go for the series and parallel connection. I believe each and everyone do have idea about the series and parallel connection. And in a few minutes, I will explain you more about the Ohm's law, and I will showcase some of the great platform you can go through it and use their simulation and stuff to showcase on different simulation before proceeding to the practical classes in your STEM and robotics classes, robotics journey. So now if I want to like combine the two batteries in some of the like series or parallel connection, what we can do, we just have to rotate it a little, not the little, in negative of 90 degree. Then the battery is like this. So I'm connected the battery to this terminal, but now again, we need to change the polarity. So I will just mirror this battery in here. So now this battery is properly aligned with the terminals of breadboard. So if I drag and drop this LED in here to like directly connect it and start simulation, so the LED is glowing, right? You can see a little bit of LED is glowing. It is clearly not clearly visible, but why this is happening? Because the power, the voltage is too low to drive the battery, and the usual voltage required to glow the LED or power up the LED is 3 volts. So what I can do in here, we will take one of these wires, and also you can choose any of the wire color from in here. So I'm just taking the green one for now and connecting the positive pin of this one, the positive pin of this one to the negative pin. And similarly, what I do have in here now, the positive of first battery is connected to the negative of second battery. So we have to utilize the uh, negative from the top battery and positive from the second battery. So now it is not possible for LED to get connected directly and get the enough power. So I will rotate again back in place with the two dots in J1 and J2 section. So now what we do have anode in here and cathode in here. And anode is responsible for the positive connection, right? So I will use one of the wire and change the color to red and take the positive terminal in here and directly connect this one to this top. So now it is connected to the positive terminal. And now what we need to do, we need to connect the negative wire as well. So I'm taking one of the wire to connect to this pin. And again, I'm taking another wire to connect this pin to the negative terminal. So if I now start the simulation, what we can see, it is like consuming more than the voltage is fine now, but the current is increased. So as I mentioned earlier, we can able to utilize the concept of resistor in between to reduce the potential flow or the current flow. So what I will do, I will remove this wire from this place and place directly a resistor in between. And now we can able to assign the desired value according to the Ohm's law, which I'm going to explain you in a few minutes. So here, if I hit this simulation, then the LED will glow perfectly without any problem and without any exclamation point. So this is the way you can do the simulation. And in last class, Souvik sir, I believe, explained already explained about the switches and all. So he showed you the example of how to use the slide switch in the circuitry, and it does have two of the terminals, right? Terminal 1, terminal 2, and the common point. So common point will always be used to supply the power. To supply the power, let me rotate this register a little bit. So I'm connecting this register in here and providing the first wiring to the terminal 1. And now what we need to do, we need to take another wire of green color, and then I'm connecting this wire to directly to the negative pin. So if I hit this simulation, it won't work because switch is turned off for now. And even though switch is turned off, and because we connected this particular green wire into the terminal 2, not in the common pin. So common pin is there, the common pin is there only to supply the power directly to the common pin. And further, we will have the terminal 1 and terminal 2. So whenever we will try to turn on this switch, it will uh, the current, the circuit between the common and terminal 1 will be connected together. The wires between terminal 1 and common will be connected together. And the time when the slide switch will be in the off condition means the common and the terminal 2 will be interconnected. So let me show you one of the example. If I hit the simulation and turn on this slide switch, then it is working perfectly, right? So LED is turning on. But what is happening in here, the the time when we turn off the switch, it supplies one of the potential to terminal 2. To prove this theory, let me bring one more LED and let me change the color to green or any of the desired color. If you can say the yellow won't look good. So let me take the green. So now this particular one is the negative terminal, right? We connected the common to the negative. So here we do have cathode and anode. So what we can do, I will connect directly the cathode to the terminal 2, and further I will take another red wire to connect the anode directly to the battery. So now the two of the circuitries is ready. Let me show you how it works and what are the reason to have what is the reason to have two terminals in this slide switch itself. So if I turn start the simulation. Okay, I forgot to add one of the resistor in here. So let me add one more resistor to supply proper voltage to the LED to glow. So I'm clicking on the resistor to change the value of it. So if I hit the simulation, if I click back again, okay, the resistor 2 is not visible because of some reason. Yeah, so now it is visible. So I'm changing the value back to 100 ohm and hitting the start simulation. So whenever the switch is off, the green LED will glow perfectly because now the common pin and the terminal 2 is interconnected. So these two pins are interconnected. So whenever we hitting the switch on the left side, so now the common and terminal 1 are interconnected, and you can see the red LED is glowing perfectly. So by using these method, we can able to switch two devices using a single switch, or we can, the switch is responsible to supply the power or cut off the power from the electronic component. That is the reason we do have switches in the electrical circuit. So if we stop the simulation and see, beyond, like, I hope each and everyone understood the concept what I'm trying to explain, right? If anything comes to your mind, or any doubt you do have in your mind, then please help me with your questions so that I can able to resolve those in the prior basis, and further we'll have more simulation and more examples to go through in Tinker CAD platform. So anyone,
Just a
yes,
quick question.
yes,
The breadboard that you had shown here is having all those things as numbered ones. Like, the columns are numbered as A, B, C, D. The horizontals are shown as plus and minus. But when we actually, purchase it online, say from Amazon, you don't
yeah.
get this design at all. Is there any, this is really helpful. Not that you can't work without it, but this is really helpful when we talk about it from the
Okay.
point of view of the children. So is there any, any place or anywhere or even online where you can?
Okay, let me grab one of the component I bought today only. Yes, the reason why you do not have that particular thing in your breadboard, ma'am, because you purchased the low quality of breadboard. So I brought this breadboard today only. Okay, let me remove my background so that it will be visible to you. So now you can see. Okay, you can see the number.
Blurred. No, it is blurred actually.
Okay. Okay, let me remove my blur completely. So now you can see.
Yeah, I can see that it is colored and it is numbered also.
And numbered also, right?
Yes.
So that is the reason why I mentioned earlier, if you are like buying anything from the market, just confirm with me. I'm not going to like earn something on that, but just help me with your doubts so that I can able to show you what are the things which are good available in the market itself. So I brought this breadboard. And how much that breadboard costed you, ma'am?
I don't know. I'm not quite sure of that. It came with a whole package.
Sorry, you are not audible properly, ma'am.
Now am I audible?
Very low voice.
Is it audible now?
Yeah, yes, ma'am.
Right. So I think it costed around 850 or 900. In the sense like it came in as a box, containing a lot of components, resistors, capacitors, transistors, you name it, you have it. You had all the wires, everything.
So help me with the
it.
site details, okay? Just ping
so
me
I
over my
purchased it
personal. Yeah,
I
ping me over
purchased
my
it from
personal
Amazon
WhatsApp.
only. I purchased it from Amazon and it came as a whole package consisting of everything inside it. Whatever that you're showing here, it was all there.
Okay, do not go with the Amazon type of package because they always send the low quality product. I bought this breadboard, I believe 60 rupees I paid for this particular breadboard. So, and because this particular breadboard is the standard one and you have to find the standard one. Otherwise,
so is it possible for you to send the link details so that we can start purchasing it from there?
Ma'am, I do have local vendors in here. Like I can able to like send it through the courier if you want me to, but not possible to buy it from the online mode. Okay, we will discuss on that, ma'am, how we can able to fix that issue, because everyone were facing the same issues to buy the component, right? And the component I do purchase in here comes in a very like obvious price and the quality is adequate. That is why I choose that particular
Thank you.
So
place to
one
start.
minute, whatever you're doing, the circuit which is done here on the breadboard, so you do it manually on using the resistor and transistor, correct, sir?
Yes.
Okay, so we need all these components to work practically.
Okay, the list of components I sent you earlier, which I'm going to use in my classroom program. I already believe I sent you some of the few component details, right?
You showed that in the PDF,
yes,
right?
you just showed.
But I don't think you sent it as
in the group itself, ma'am, I shared those
sensors.
details.
You showed some sensors. Sensor.
Okay, that was the sensor. The name of sensor was the part of the LMS thing we do have.
I think I have missed the bus. Is it possible for you to send the list again, if you don't mind?
Again, yes, absolutely. After this class,
Uh,
I'm going to write down each and every parts we require to have the practical projects. And yes, yes, PR sir, you mentioned list of 20 items. Yes, apart from the small components, I mentioned few of the sensors and Arduino board and all the things which will be required for this classroom as well as for your future journey in STEM. So if you are buying something from somewhere, just let see the what they are sending to you. Otherwise, do not invest money on the breadboard, because these breadboards, like one of the breadboard I purchased in my college time in 2014 at the price of 180 or 190 something, it is still working perfectly. There is no issue on that particular breadboard, and breadboard do not get wasted throughout the journey. So you can able to reutilize these things in your future projects. So okay, fine. So let's proceed further, and I will love to share some of the insight or the experiments related to the circuitry and electricity. So I will share by today midnight only the links. Those who submitted their email ID for the LMS access, I will enroll each and every content in there.
I
So
sent my details, but I didn't receive any LMS details.
okay,
I
I
submitted the
received.
form.
You already shared your email, right? 68 of emails I do have with me, which I sent the link on the first or few classes, one or two classes.
You had sent a form. I filled in the form and submitted it, but I haven't received any
Okay,
LMS.
though. Okay, no worries, ma'am. I will look into it. Just help me with your details in my personal WhatsApp so that I can able to send you or resolve this problem for you. So now what we do have in the LMS itself, you will get the access to these things as well. So you can start the simulation to learn about more about the electricity, and also you can help your student in your classroom program to further experiment with these stuff first. Then only they will go for the practical demonstration or practical projects. So if I bring one of the light bulb in here and I drag and drop one of the battery in here, and similarly if I bring one of the switch, then using the wire I'm connecting each and everything for your understanding. So now this and further this. Okay, this won't work like this. So let me connect it back and this wire to this one. So if I hit the switch, then what will happen? The circuitry is complete. The reason why I'm showing you this simulation, you will understand in a few minutes. So I'm just disconnecting everything and I'm grabbing voltage like voltmeter and ammeter. And please, if I forget to mention in the kit itself, please buy one good multimeter for you. Okay, then it will be great addition in your lab bench work. So I do have the negative terminal in here. So I'm placing the negative point in here and positive point in here. So if I hit this switch again, so it is drawing the voltage, but it is showing in negative terms. So I have to change the direction of the connection. So I'm connecting these two in the opposite direction. So now what I will have whenever I will when I will close this switch, then electricity will start flowing, and you can see the formation of LED, like how the electron is flowing from the battery to the bulb and through the switch itself. So if I bring one ammeter that is only to detect the current in the circuitry. So if I place the ammeter in here and close the circuitry, you can see how much current it is withdrawing, 0.09 amp. And the reason why I'm showing you this experiment, because let me open this circuitry and further add one more battery. So what we do have is the series and parallel connection on our earlier classes. So let's make one of this series connection first using the battery. So I'm connecting the wire directly to this positive side, and what we do have in there is battery is connected in series way. So if I close the circuitry, you can see the voltage. Okay, the voltage is not changed because the wire got, yeah. If I now change the close the switch, then you can see how many voltage we are getting, 18 volts in total, and the current capacity is 1.8 ampere. So if I change the circuitry a little bit, and if I change the circuitry a little bit, suppose if I connect the batteries in parallel, then what will happen? Let's see the practical demonstration of series and parallel connection. So now I connected the wires to the below terminals and again to the upper terminal, and now I'm connecting this wire on the upper terminal. So if I place the voltmeter again in this place, and here this will be the positive one. So let's see what will change in this circuit. So now what we do have is the voltage in total 9 volt, and if I measure the current flowing through this wire, you can see what is happening. The current flowing is reduced in parallel connection, and voltage also 9 volt in total, because one battery does have the capacity of 9 volt. But in series connection, we observed that the voltage is doubled, as well as some of the amperage, like the current carrying capacity, also increased in total. So through these kind of experiments in these places, like we can also employ some of the fuse in between. So using this simulation, you can also let your student understand the concept of STEM in proper way, so they can able to visualize each and everything, like the how electrons are flowing through the circuitry. This is how I am taking the classes in my classroom program. So I like showing each and everything, like the demonstration of what will happen if we bring the normal dollar bill or coin or paper clip, and I show them the concept of how what are the metals, or what are the devices or things do have the electricity carrying capacity, and some of the devices do not have electricity carrying capacity, using these experiments. So if I close the switch again, nothing will happen, right? So if I drag and drop these things out from the circuitry, if I bring one of the paper clip in between, then we can see the changes in the circuitry itself. So whenever the switch is closed, so you can also show them the concept of like how different thing works for the junior classes, not recommended for the senior classes. So apart from this, what I do have for you is the concept of electrical resistance. Like whenever we speak in terms of electrical resistance, you already know about the like the Ohm's law. So in Ohm's law, what we do have is the relation between V and I, right? V and I. So how it is correlated? V will always be proportional to I. To remove this proportionality constant, what we try to do is to introduce one of the fixed value or one of the constant. So in here, R is the constant, and R represents the value of resistance in the circuitry itself. So this is how we can able to do the combination of utilize this concept, the Ohm's law in our classes, because Ohm's law gives us the ability to calculate what is the required value, what will be the required value of I, V, and R in our circuitry. So suppose if we do have one of the LED which works on 0.30 mil or ampere, 0.30 ampere, and it does require 1.5 volt to operate, then we can able to calculate how much resistance it will create, right? This is how you can able to calculate the exact amount of resistance required in your circuitry. Then you don't have to ask me the question like why we are using the 100 ohms and why not to use the 200 ohms, because most of the LEDs do have the power rating of 0.3 amp. So we can utilize these Ohm's law concept to find out the value of other required thing like the resistance itself. So even though if we do have some of the resistance fixed in the board, and we do know about the voltage flowing in the circuitry, then we can, using this relation, we can able to find out the concept of find out the value of I as well. So this is the reason Ohm's law, the understanding of Ohm's law is important for you all. And the factor affecting the electrical resistance is all about like the cross-sectional area. The class 10 student do have a brief idea about these because they do have each and everything in their syllabus as well. So in earlier classes, I mentioned one of the point, the resistance will be dependent on, okay, sir, please give the class code instead of the link. Yeah, the class code is itself on the link. If you see the last 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 digit from the last of the link, PR sir, one of the person, PR sir, the last is the class code only. Okay, I will give you that after this demonstration. Okay, wait for me. Just wait for me. I will give you that, sir. So now if I talk about the factor affecting the resistance, then we can say there is one relation, and I believe each and everyone do have the idea of what I'm going to write in here. So R is equal to rho L upon A. Maybe you already read this before, studied this before, this relation, while while calculating the resistance or calculating the resistance for any specific conductor. So R in here is the value of resistance, how much resistance the metal will create throughout the section. So rho is all about the material of conductor. So material of conductor means what is the metal or something we utilize to build the conductor. So metal, either the copper or silver, gold, and so many things we do have as a metal to conduct the electricity. So it will be dependent on the metals we are choosing for the circuitry. Apart from this, what we do have is the L, and L is all about length of the conductors. The more the length will be more means the more resistance we will have on that conductor. And A is inversely proportional. So if I summarize this thing like this, R is proportional to L, R is inversely proportional to A. Means whenever the area of cross section increases, then what will happen? The resistance will decrease. If the area of cross section is increased, means resistance will decrease. And further, what we do have relation with length, whenever the length will increase, so it is directly proportional. So resistance will also increase. If length will increase, then resistance will always increase. So factor affecting the resistance is 4, the cross-sectional area, the length of the conductor, the material of the conductor, and yes, the fourth one is not mentioned in the equation, but yes, the temperature of the conducting material is also responsible to change the resistance of it. So we do have R is equal to L by A, which is not true at all. R is always equal to rho L by A, because we do not keep track of the rho value, the rho. That is why it is written R is equal to
Sorry,
L
can you
by
just
A.
explain a little more about the rho?
Yeah.
Can you explain a little more about rho? What is rho? How do you find the value of rho?
Okay. We cannot able to find the value of rho, ma'am, because it is fixed for each and every material. So rho or symbol rho, you can find it over the internet as well. It is written as RHO, and it is fixed for each and every material we do use. You will find various like data related to the material we are using. So material with a low value of resistivity conduct electricity very well. Okay, here we do have is the silver, copper, aluminum, wood, air, and Teflon. You can find out these values of like how much resistance or resistivity the material will create per per uh, per unit length and per unit what we can say per unit length and per unit cross sectional area. So you don't have to worry about these things, because these things not going to affect any of the robotics classes. That is only for your knowledge improvement in this topic. That's all. So if you want to further
Yeah, got
understand the
it.
term,
Yeah.
if you want to further understand the term, then I will help you with the PDF of that thing to calculate. So the major thing we are here for today is to understand the resistance process, as well as it will give you the proper ability to calculate some of the resistance without looking into the value written from the vendors itself. Suppose if you do have any of the resistor and you have to find out the exact value of resistance, because whenever you will buy some of the resistance from the market for say 1 kilo ohm, it won't always be same. Like it won't be it is not possible to have exact 1 kilo ohm value of resistance. So it will come under tolerance, like plus minus 10% or something like that. So always it will nearby to the 998 ohm or 999 ohm or 970 997 ohm kind of things you will receive in your multimeter reading. So to find out the value like this one, the 1k value from the register itself, you will please remember this chart. This chart is only to identify the bands as well as the multipliers along with the tolerance. So first band represents the value, and to remember this, just try to remember one word which I made earlier for myself. So BB Roy, GBB, GWGS, GBV, and GWGS. So this particular thing will be helpful for you to remember the value of resistance. So B stands for black, again brown, R stands for red, orange, yellow, green, blue, violet, gray, white, gold, and silver. These two on the last side, the gold silver is rare and it is only used as a multiplier, or we can say that the tolerance in the resistance itself. So remember the other words. So whenever you can see there, we do have the red band, the orange band, the violet band, the black band, and the brown band at the end. So how we will calculate? Red does possesses 2. So I will write down the value 2 in here. So again, what we do have orange. So orange does have the value of 3. So I will write down the 3, and the violet does have the value of 7. So I'm just writing down the value of 7 in here. And apart from this, what we do have the black. So black will be the fourth band and it will come under the multiplier itself. So we will multiply these with 1 ohm, means 237 combinedly get multiplied with 1 ohm, and further it will result in 237 ohm. But we are not limited to 237 ohm, as we do have another band in here, and this particular band is brown. So brown represents the plus and minus 1% of tolerance. So what we can say, plus and minus 1% of tolerance. It means 237, the value of this resistance is 237, that is for sure. But it may be possible that 237, apart from the value of 237, there will be 1% chance in reduction and addition, means it may be 238 or 236 or something like that. 1% of 237, it will increase or decrease in both of the direction. So this is how we can able to calculate the resistance if you do have resistors with you. And yes, in the robotics projects you need those resistors, because sometimes what you need to do is to utilize the resistance in between the electronic component to decrease the value of voltage in the electrical circuit. And you will need these stuff in your classroom program, that is for sure, because I find myself in a situation where I have to utilize resistance all or most of the time. So please remember these particular terms. And if I look into the series and parallel connection, suppose if you do have register with you and you do not have a specific register with you, you do have some other values, then you can able to combine the register in series and parallel connection to find the desired output. Suppose if you do have 1 kilo ohm register with you and you want the 3 kilo ohm register in total, then what you will do, you will add 3 of the resistance in series to have the 3 kilo ohm in total, and apart from this, if you do have resistance like let's say 1 ohm, or not the 1 ohm, 10 ohm, let's say 10 ohm. And if we calculate the resistor equivalent, then we can say 1 by R1 is equal to, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here we do have is the 10 ohm. So 1 by 10 plus 1 by 10 plus 1 by 10. So now I'm taking the 10 as a common. So 1 plus 1 plus 1. So 3 by 10, or we can say 0.3 ohm. So remember the term why I calculated this in front of you. Whenever we connect anything in parallel, like the resistor in parallel, whenever we connect resistors in parallel, it will always decrease the value of resistance. It will always decrease the value of resistance. But whenever we connect the resistance in series, then what will happen? It will always increase the value of overall resistance. So you have to keep this in your mind to calculate and further utilize the resistance or a resistor in the process itself. So whenever you want to have like higher value of resistance, then yes, you can able to add those in the this series connection. And whenever you would like to have the lower value of resistance out of your high value resistor, then you can utilize the parallel circuit connection for the same. And yes, one person commented, PR sir commented, that Greek letter rho represent the resistivity of material. The resistivity of material is the resistance of a wire of that material of unit length and unit cross sectional area. The unit for resistivity is ohm per meter found on the net. Yes, sir, that's true. That is what I explained earlier. The same unit per length, per unit length, and per unit cross section. So you can either utilize both of the combinations to form the specific resistance value as the equivalent, or we can call it as resistor equivalent of resistance. So you can utilize the same in your STEM classes to find out equal value for each and everything. So now you do have any doubts in this section, the series and parallel connection, sir and ma'am? Any other doubts so far? Let me do the experiment with the Ohm's law then. If you do not have any doubt, then it is great for me to explain the further process. So as I already explained you about the Ohm's law, right? And why it is required. So Ohm's law gives us the definition of how voltage, current, and resistance are correlated, right? So as per the Ohm's law, it is not about the V is equal to IR. Ohm's law states that V is proportional to I. Means voltage in any electrical circuit is directly proportional to the current flowing in that circuit. So in here we need to remove the proportionality constant, the proportionality symbol, right? Then only we can able to calculate some of the data. To remove the proportionality constant from this equation, what we have to do, we have to introduce one of the constant. Like when we are removing the proportional sign and placing the equal sign, then we have to introduce one constant, and then the R comes into existence. And here R represents the value of resistance in an electrical circuit. So this is how we can able to correlate these three things together using the Ohm's law. And let me show you one of the simulation in here, which is essential for you to understand in this classroom program. Okay, let me change the value of voltage. We do have one of the things to control the voltage, and one of the adjustment thing to change the resistance. And we are keeping the I is equal to I constant. So let's see what will happen if we increase the voltage. So whenever we try to increase the voltage in electrical circuit, the current flowing will also be increased. Like the thing happened in our earlier simulation, right? This simulation, whenever we try to add the battery in a series connection, the circuitry also showed the gradual change in the current itself. So whenever we change the voltage, whenever we increase the voltage, the current flowing capacity will also increase into the in the circuit. And whenever we reduce the current, then the current also reduced in the thing. So what we do have, Okay, fine. So now let's see the relation between the resistance itself. So whenever we increase the resistance, then the current flowing through the conductor will decrease, right? And whenever we reduce the resistance, then the current flowing capacity will increase. And through the through the equation also we can able to understand the same thing, like because v is directly proportional to I, right? So whenever v will increase, I will increase. Whenever v will decrease, I will decrease. And now what we do have, v is equal to IR, and we can say R is equal to V upon I. So if we increase the value of R, then what will happen? The overall value for V and I will also increase by some extent, right? So we can able to correlate these things together to find out the exact value of other physical dimension in this equation. Like if we do have V and R with us, then we can able to find the value of I. If we do have V and I, then we can also able to find the value of R, and vice versa. So you just have to utilize the concept of pure electronics to make this thing work in your classroom program. So now we do have that example. Let me show you one of the video which I prepared earlier. So series, let not waste time in this video, because you can also able to access the video in the LMS portal, and it will be activated by today only. So let me go back to the Tinker CAD platform, and I hope the series and parallel connections, the doubt related to series and parallel connection and why we need a different resistance and the voltage output in the circuit is clear for you, right? Anyone do have any doubt still? Then please help me with your question.
We will have to do it, and then only we will be able to know.
Ma'am, your voice is too low. I'm barely can able to hear you out.
Are you able to hear me now?
Yeah.
If only I do it, I'll be able to say.
Okay, fine. Then what I will do, I already created one of the activities in the Tinkercad platform. Okay. So by today, I would love to see, I will share one more PDF with you, which I already believe I shared with all of you. The circuitry portion of Tinkercad. Let me show it to you once. So this particular PDF, I believe I already shared with you earlier. So this particular, okay, one thing is missing to be explained, then I will further add some of the things. So this PDF I already shared in the group earlier, but if you want me to share it back again, then I would love to share that with you all. But in the meantime, I would love to explain one more button in the Tinkercad platform, so that today this chapter will be closed, and by tomorrow we can start our programming lessons and different project building activities. Then only we can able to utilize proper time in our classroom program. So let me bring one of the push button, and if I, okay, just let me go to the full screen. And yes, so now what we do have is the let me remove the slide button as well from this equation. And now what I want to do is to bring the, and let me delete one more LED from the equation, one more resistor, and this wire from the equation. So whenever you try to utilize the push button, then always remember to connect the terminal diagonally. Never try to connect it parallelly or like vertically. Just remember to utilize two of the pins diagonally. Then only it will become a great example for you to like show it to the student. So if I start, sorry. So if I hit on the start simulation button, and if I keep pressing the push button, then only it will glow. Otherwise, the time when I lift up my mouse from it, it turns off the device. So the push button is useful in our circuitry, because in future examples, when we start our Arduino lessons, we will utilize push button to at least provide the inputs to the system or the programming or the brain itself, like the microcontroller Arduino. So we will use several push button in different projects And the reason why we'll use the push button, because it is only SPST type, like single push, single throw type. I believe that I already explained the term about different switches, right? SPST, DPST, DPDT, and DPST.
I'm afraid not.
Okay, I have not explained that, or okay, I will summarize those then. Okay, fine. Now, what we do have is other things as well, like the sensors and all. So by today, just try to complete each and everything in the Tinker CAD platform, so that arrange each and every circuit. And I will love to give you the assignment by today only. If it is not delivered to you all today, then please wait for another day. By Sunday morning, you will receive the assignment in your LMS portal itself, and I will activate each and every section for all of you. So then only we can able to utilize other stuff as well. So complete the analog circuitry by today, then tomorrow we'll have the programming lessons for the same. So I'm concluding this session for today. So now, if anyone do have any doubts about anything which I showed you or explained you, then please help me with your question. Okay, let me stop the